How are we doing? Wednesday. Wednesday. It's kind of interesting. So usually for Tic Tac, um, you like the music? Yeah, I love it too. Um, Usually in a main semester, I have Tic Tac Monday, Wednesday, Friday, right? And Toe is Tuesday and Thursday. So usually have a nice weekend is to Tic and Tac on Friday. But the last class that I have with you, kind of like in the middle of the week, you know, in the summer on Wednesday. So well, see you next week. But it's not really weekend. I feel a little bit off. But anyway, hope everybody's doing okay. Any question for me? Any question for me? Midterm, right? So midterm questions, right? Oh, great! I'm doing great. I'm doing great. Busy though, but feeling good. A little bit pissed yesterday to hear the news from the other day, actually, not yesterday, from Monday, to hear the news from the ICE police. Everybody heard the news, everybody, that they are not allowing international students to our international classmates and friends to take classes in university that offer, online instruction only. And that is crazy. That is crazy. Totally crazy. I mean, this morning, I've been in contact with department, the Office of International Programming programs to see what they say, and the university. And our school hasn't yet has any response to the situation. Um, so MIT and Harvard this morning filed a lawsuit against the Trump administration. There's a petition that I post on Island. So if you have time and you want to contribute your voice to help our international classmate, yeah, that would be nice. So that was the first thing I did right away. I looked if there's any petition and I found it. So I post on Island to share with us. Yeah. So Kevin, yeah, also Berkeley and a couple of school are thinking about creating a one unit class. In person, can be yoga or anything, and attendance is not even required. And they try to lower the tuition fee as well, just to cope with the situation, because there's only about a month, right, before a month or a month and a half before the August starts. So they're gonna create an in-person class just to deal with the situation, like Kevin is saying, for international classmate. So anyway, where did it start though? And where did it start? It started with the trade war, right? So Trump and China, and he basically lost the business, war to China. So he tried to find something else to fight back, and he used education. The problem is that education is one of the strongest industry in U.S. Right? All the famous university here, and people come here to study. I don't know why he would take on that. Yeah, and for SF State, we are the biggest international school in America. We are SF State, the school with the largest number of international students. And our school hasn't has any response to this yet. I called the Office of International Program this morning, and they say that they are waiting, and maybe by the end of the week they're gonna have some action. And of course, they have to listen to the San Francisco State University system at the same time. So yeah, it's uh, it's pretty much unbelievable. I don't see. Yeah. Um, I have a meeting with the department on Friday, so we'll see. What kind of instruction we have for our international classmate. Is that okay if I ask? How many classmates in the room are international student for our class? You are, right? Can you give me a green dot if you're okay letting the everybody know that you are international student? Okay. And are you registering for the for the four guys? because I want to see what I can do for you. Okay. If you have any concerns, send me an email because I want to get involved. I don't agree with what's going on, and I've been contacting the school. Tuition already paid. Also, I know it's unbelievable. Well, their argument is this. All right. If we want to fight, we have to understand their argument as well. Um, International student, right, usually are allowed to take at most only one online class. Okay, so that has been the rule. And because of last semester, the movement was in the middle of the semester. So actually, the ICE they gave an exception last semester to allow everybody to take online classes. However, this is a situation is almost like a natural disaster. Who can stop this, right? And especially the virus is spreading. Okay, so it's true that there was a law, but they supposed to make the law, more flexible, right? For the situation, especially it has to do with education, human, right? And most importantly here, people who are studying, but now they are making it harder, and then it doesn't make sense. Anyway, I'm being pissed about that situation, so I should not talk longer about the issue. But send me an email if I can help you. Okay, um, send me an email if I can help you with anything. I do understand that things takes time, but our school is responding too late to this situation. I believe that they should have done more. Especially we are the biggest school, of international student. The situation came out on Monday afternoon, right? So and now it's already 48 hours, more than 48 hours, and there's no response. That's a little bit slow, a little bit slow. At least if I were them, if I were the university administration, I would send out an email to everybody, you know, support your international classmate, right? And should send an email to all the international students. We are here to support you. Please contact us right away if you have questions. Yeah, we are doing everything for you, but we haven't heard anything so far, so that's kind of slow. All right, if they are slow, we got to be fast. Any question for the midterm, everybody? Any question for the midterm exam? Let me get a green dot. Who saw the midterm post on Island, please? If you saw the midterm, please give me a green dot, right? Okay, because it's due on the weekend, so I want to make sure that you get it before you see me again next week. Okay, most of us got it. Okay, that's good. Um, I gave you more time, right? I try. Initially we thought of having it due on Saturday, but I try my best to give you all the way until when, everybody? Until when? The midterm is due when? 6 p.m. on what day? Sunday, right? Everybody's good now? 6, not 12, not 12, not 12. 6. 6, right? 6, that's mean 18, right? Are we all good? 6 in the afternoon. So everybody please, okay, write down on a piece of paper on your phone 6 p.m. on Sunday. And then after that, I need the time in the evening to grade the exams. So Monday morning when you wake up, you have it, the result right away, right? So 6 p.m. Okay, all right. And then let me take all the question, please. Who has a question for me? Who has a question for me? Who has a question for me? Let me see where the assignment is. It is here, midterm exam. There we go. Okay, any question for me? Okay, Jay, you have question? Go ahead, please. Oh,
You hear me?
okay, I hear you.
So for the question that's asking for the area of like the variables or yeah, do you know that question? That's
Yes.
stored. So it says why it is stored there. Like where is its lifetime and why? So
Mm-hmm.
you've explained where they're stored, but you never explained exactly why it is there. You know what I mean? It's like I know where it's stored, but I don't know why it's stored there.
Oh, for example, let me say, if you have a local variable in a function, where is it stored, Jay, and
Uh,
why?
look, which, say it again.
If you have a local variable in a function call, where is it stored?
It's stored area 2
Okay, and why?
because it's local.
Yes, and it's a function call, right? It's an
Yeah.
activation record, right?
Okay. Yeah.
Yeah, see, you know it. You
That's
just
it.
ask a question and you know it.
Okay. I thought you needed more explanation than that.
Well, you can always expand on that, but that's a good start, right? And you still have all the way until Sunday to think about it. And today, and I also post package 7, package 8, and we're gonna work on that today, actually, Jay. So good question. You can do it, and we will practice today too. Okay.
Okay. Cool.
All right. Thank you for the question. Who else, please? Is that Joel has a question? You have a question for me, Joel? Is that about the submission? Submission is on Island, everybody. There we go. Midterm exam submission, right? Is it supposed to be in PDF or in what, everybody? Supposed to be in what? In PDF. Okay. All right. So any other question here? Any other question here? Everybody, please take a look at the midterm and let me know if you have any question, because I won't see you right another time before it's due. Right, it's due this Sunday. So please give me all the questions, please. Any question here? Any other question? Any other question? One file, one copy. It's there's office hours every day, Monday to Thursday, Edgar. Right, and I've been having some volunteer office hour with some classmates on the weekend as well. No problem. By the way, anything about where things are, what it is all on File Manager, right? I gave you the syllabus on the first day of class, and I also post them on File Manager. So we need to submit Part A, Part B, and Part C. That is correct, right? That is correct in one file. And the file that I gave you is in Word document, right? So you can just go and just work on it. Is that okay? Yeah. And then after that, save as a PDF. Why always save as PDF? We talk about that first day of class, right? You want to make sure that the client see exactly what you see, right? So uh, I know that some of us work on phone a lot, so I still share with us PDF versions of the exam so that you can take a look. When you're at work, when you're around, and then when you are on your computer, then you can use your doc, the Word format. Is that okay? Right. So I do try to make it as convenient for you as possible. Okay. 5 seconds, right? Let's count down here. If there's no other question, we're gonna continue with our lecture. Okay. Last time we stopped on line number 424. 424. If you have any last question, let me know, everybody. If not, we open our package number 5, line number 424. Thank you, Isaac. 424. 424 means four. Okay. Okay. 424. This is very good. So now let's go to the next page, because on the next page, there's a question to help us kind of recap what happened last time. So let's turn to the next page and take a look from line number 425 to line number 455, right? Um, oh, wait. Oh, wait. This one we finished already. We finished this one already. Yeah, we finished all of this already. Okay, we are done. We are done with the package. The 425 was assignment 2, right? Can you still see my iPad, everybody? I saw something just pop up. Oh, okay. That is good. So let's move to line number 522, everybody. 522. So what I gave you on line number 522 is this. I gave you, take a look at it first, please, and then I explain to you. 522. There you go. So on line number 522, and then if you keep scrolling all until next page, all the way until line number 612, right? So what I'm giving you here is that those are important terms. Oh, no screen? Okay, let me see what's going on here. No screen. Uh oh, my iPad is not even in the room. Okay, I will see you soon. I think I have it on for too long. There you go. So I asked the department to create a place on island for you guys to hang out, right? To see people, to work with each other. But it seems like it's taking them too long. So they have so many things to do, and I'm gonna do it. So I'm gonna do it. I'm gonna open a place on Zoom for all of you, and we're gonna use that space now. And my I have 5 classes in the fall, and I manage 6 other classes for the College of Science and Engineering. So totally is 11 classes. So I know that's enough number of classes to use that space to hang out. So I'm going to open that Zoom space soon, and then we can use it. And in the fall, our classmate can use it as well. I hope that it will be useful. Okay, so here we go. Can you hear now, everybody? Can you see now? Can you see the screen now? So on line number two, thank you. For line number 522, I'm giving you the concept that we already been working on. And what's important here is this: when you get to advanced classes, everybody, and especially when you go to job interviews, right? Sometimes we get hung up just because of the terms that we don't understand. So when you have time, right, I want you to please look over all the concepts here that I summarize for you. Those are the things that we've been using, in our assignment. Sometimes we understand, but we just don't have the term to express, what we are doing. He is not seeing. Is that he means me? What I'm supposed to see, Jay? Are we doing okay? We left at 3:34. We skip 100 lines. No, we did not. We did not, everybody. We did not. Let's see. Oh, we are the tick section. Sorry. I was thinking that we are toe section. I'm very, very sorry. Okay. Anyway, since we are here, right? Let's finish this part first, okay? So, what I'm doing here is that I'm giving you all the terms that have to do with design concept, right? So, design concept, that's what we've been working on for this assignment, for the assignments in this class, right? So, make sure we understand the general concepts such as abstraction, refinement, right? Modularity, right? Software architecture, control hierarchy, structure, partitioning, data structure, software produce, information hidings, right? You actually know all of those concepts. But if they mention that and then if they use those, in interviews, sometimes you can, you don't understand and get very confused. And when we design, right, our program, what are the things that we need to consider? So in this class, let's see here. For example, we talk about usability, right? We talk about performance. We talk about scalability, okay? And there are other concepts that you are supposed to learn in 413 as well, okay? In C++, we're going to continue to talk about compatibility, right? uh, Extensibility, it has some common with scalability, okay, and both of them means no hard coding, okay. So please make sure that you take a look at all those terminology that I give you at the very end to uh, GUI, graphic user interface. That's usability, Jay, right? That has to do with usability. Okay. Um, Usability on line number 603. Did you see it? Usability, right? And also about line number 597, we have reusability, right? So that has to do with line number 586, modularity. Okay. So I will get back to all those terms another time with you. So please just read ahead, and then we're gonna discuss more. But most of this we cover already. This is just a part of me preparing you for 413. Okay. Usually in our class they don't discuss all of this, but I like to give you everything that you need to succeed. All right, so what line number we left off last time? 334. Sorry, 334. So on line number 334, okay, we still have our mark here. All right, so 335 to 361, let's do it. 335 to 361. What's going on is that, let me go back a little bit here. Remember that last time we learned about L and R values. Everybody's good? So now I'm going to read the definitions again, and I hope that it's easier for you to understand. If you don't, please ask question, right? So 301, L value is an expression, right? It is an expression. It's not just a variable, it is an expression, right? That identify a non-temporary object. So we are talking about having a name, a label, or an ID that may give us access and control over an element that is not soon to be destroyed, right? It's gonna be there. Maybe it's the whole lifetime of the program. That's what it means by non-temporary. R value is also an expression, but we may not have a name, we may not have a label, and we may not have an identity, and most of the time we don't. So the first identify keyword means name, label, and ID. But the second identify on line number 302 actually mean is to classify. Yeah, exactly. It's more like classify. Is to highlight the characteristic of the temporary variable rather than giving you an ID. Sorry here. So a temporary object is an object that is soon to be destroyed. It may last only in the parameter scope, right? In a very small scope. It's there for a moment and it will be gone. And sometimes it's just there because we want to flip the state of a variable. For example, from L to R or R back to L. When we use a move, right? When we use a move function, which I described to you on line number 331. What does move do, everybody? Let's recap here. This is a very important function. What does move do? What does move do? Can some of us explain here? What does move do, everybody? We learned last time. What does move do? Move, that would, it gonna convert R to L or L to R, right? So it's two ways converter, right? Thank you, Kevin and Tony, everybody. And when you say, for example, if you have this piece of data, right? For example, you have one in there. When you are converting, are you moving that data to some other place or not? This is the most important point when it comes to move. And this is the heart, okay? This is the core of, more than C++. Okay. So when you have a piece of data, right? When you have a piece of data and you use move on it, are you physically moving it away to a different location or not? Anyone? Are we moving it away to a different location or not? If we understand this, the next two packages will be easier. Yes or no? Who say yes? Who say no? If we put a we no, that's right. And the answer is right there. Here we go, everybody. If we move Mickey, right? If we start out at 9E4, after we move, it's still 9E4. Everyone's good? So there's no movement of data at all. The data is still at the same place. That's how we save memory. And that's how we save processing units. That's how we save, the copy operation. Move versus copy. That's what we're going to learn next. Okay, this is the most important topic in modern C++. Move versus copy, or copy must move versus move, right? That's how different they are. Okay. All right. So now let's I give you another example to recap everything that we learned about L and R value. On line number 388, we have a function, everybody. And then with that function, I give you five ways. Five ways. One, two, three, and four, and five. So I give us five ways, okay, to use it. So now let's look at the five function calls and five different ways that we receive the return value. And we want to look at those examples through the L and R value lenses, right? So now in 10 seconds, okay, and please use 10 seconds, try to answer the question of what is going on, why is that, right? And is that a good way to do it? And which one is the best? All right, so 10 seconds. This one is wrapping up the whole package. So please take your time there. What is happening? Why is that? Is that a good way to do it, right? What is a better way to do it? I can give you some more information here because this piece of information is very important. Let me try to recall here. This one should be C++ 2000. This this one is 2011. C++ 11. This one is C++ 11. All right. That gonna help us a little bit here. Oh, transfer student can start getting classes today, I think. Because I got an email from the department saying that they stopped hiding my third 340 section. They've been hiding it. They've been saving it for transfer student. Okay, how are we doing, everybody? All right. So, um, problem solving. In order to analyze those five methods, what would you do first, everybody? If this was an interview, what would you do first? What would you do first? Who's a problem solver here? Who's the problem solver here? And we learn a lot, right? From the beginning of this package. Talk the problem out. That's very good, right? So you talk from what line and what you talk about. You talk from what line and what you talk about. Point out the differences of each test. Very good, right? Is there anything else we should do? Is there anything else we should do here? Are we are we looking into the small picture or big picture? Remember that the way that we answer questions, right? The way that we problem solve during an interview uh, tells a lot about us, and the employer always observe that. They want to see whether they can work with you or not, or whether you are someone who has a problem solving technique. You have a process, and you can work with other people. So if it were me, right, in an interview, exactly, look at the scope, and we have to take the big picture in first. So when they give you one, two, three, four, five, right? Most of us would jump into one, three, four, five, but no, we learned, from the first package to all the way line number 340, 34, that in C++, the core matters, how we receive it matter, how we return matter, and how we receive the return matter, right? The first receive was the parameter scope, and then the other receive is when the caller receive the value return. So we have to get back to line number 338, everybody. That's what it means by big picture in this case, right? If we don't know what return value is producing and returning to us, then it doesn't matter 1 to 5 what method that we receive the result. Do you agree with me here? Right? So always try to step back. Try to step back. I give you one trick, okay? If you are sitting in an interview room, right, and you see yourself start leaning forward, if you start leaning your back forward, right, and very close to the interviewer, you are being in a very passive position, right? Because you are losing the big picture. You are trying to lean forwards, almost like desperate to convince the interviewer. And the more you lean forwards, you are not relaxing to see the big picture. So keep your back straight and try to, sit straight and go back. And that's what the book says. And it's true. I believe that. So they read body language as well. So over here, what we got is this. On line number 338, right? You have this return value function. And then on line number 339, we are declaring, you know, uh, on line number 339, CS is what, everybody? CS is what? 339. CS is what? Everybody, CS is what? CS is be careful now. CS is what? On line number 339. We learned this last time. What is CS now? CS is an R value reference. Are we all good? Right? It's an R value reference. That's how we want to look at it right now. It is actually an R value reference equal to the R value on line number 340. That's what we learned last time. Everyone's good? Right? Okay, be very careful now. And then on line number 340, we output the address of CS, right? And then on line number 341, this is the biggest question that we need to know here in order to, start analyzing the five ways that we make the call and receive. On line number 341, everybody, what are we returning? What are we returning? We are returning what? We are returning what? We are returning what? On line number 341, we are returning what? We are returning. We are returning what? 340. That's right, Joel. Very good. We are learning. We are returning 340. We are returning an R value. This is the most important point now, and it is not as simple as it looks. Right? It is an R value, and it is not the R value up here. Right? This one up here on line number 339, we use it and it's gone. Right? That one's gone. This is a 1 3. This 340 is the value that we store in the memory address in the memory slot of CS. And now what we are doing is that we are detaching, right? We are detaching the 340 value, and we are returning to the caller. How do we know? How do we know, everybody? On line number 338, we are saying that we are returning a value, and we are knowing, and we can see it better than that, right? In 210, we say we are returning an integer type. 2 weeks ago, we say, no, first week of this class, right? We are saying that we are returning a deep copy. And then from last class, we know what? We are returning an R value. This is a very important point. Okay, if you go to an interview and they say, can you give me a good example where R value matter? It is this example right here. How is this an R value wasn't CS declared as an L value? Okay, so this is what we discussed on Monday, right? For a very long time, Jay. Remember we talk about this statement up here. Remember we talk about this statement up here on line number 313 and 316. The two star are still up there, right? Remember this? This is old time C++. When we say, string, str string, and it looks like an L value, but it wasn't. It wasn't, right? It wasn't, because if it is an L value, on the right side is an R value, then that assignment would never work. Are we all good? And then we discuss how over here that's all illegal, and the solution for it is to use a R value reference. So in the new time, in the modern C++, this statement on line number 313 actually means this statement here. And that is R value reference, right? That's last time we spent a lot of time talking about this point here. And then on the right side, we also talk about this, the sequence where we declare the variable, giving a value, recognize the address. But the right way to do it is what? We are having an R value first. That's what's happening, everyone. And then we are giving it a reference for the first time. And that is actually an R value reference, because L value, right? L value reference, we can only have L value reference to reference something that already have a name, right? L value reference is another name giving to an existing object that's already have a name. In this statement, right, let me clean it up so it's easy for you to see. In this statement here, everybody, on the right side, we have CSC 34, right? It is an R value. It is a temporary object. There's no name yet. So if we are giving a reference to an object that does not have a name yet, we break the definition of a reference already, right? In the in package number 3, we say U, right, means S, and we were able to create U because S is existing. S has a name. S is an object. S is already an L value, right? But in this statement here, on line number 313, it doesn't make sense, because on the right side, it is an R value that has no name. That has no name, no identification, right? Not it's a temporary object, then how can we give a reference to it, right? That's why L value here doesn't make sense. In the modern C++, we got to write it like this, double ampersand, because we know that we are referencing an R value. So we have to give it an R value reference. And R value reference start with the double ampersand. Everyone's good here? So now, all of that's right, all of that, why it matters. If we can analyze, what really happens in the background to this point, then all the five example at the bottom will be very easy. But if we don't see this first, as we analyze from 1 to 5, we're going to get confused ourselves. Okay, so if we understand this already, on line number 346, very simple now. What are we doing, everybody? What are we doing on line number 346? A very simple keyword can explain this, right? What is that keyword? What are we doing here? On line number 346, we are in the main, right? We are in the main, and we are returning a an R value, and we are giving it to a different object, and then they have no connection to with each other. What are we doing? Across the scopes, we are making a deep copy, right? We are making a deep copy. That's all. Does it make sense now? And we are having no problem with memory or anything. Now you start to see the beauty of this, everybody. When you return by value, so you get something done in here, right? And you know that this activation record is soon to be gone. You are saying this, I'm going to have a return that have nothing to do with the existence of this activation record. I'm going to return an R value. It's totally, you know, temporary. It's totally an R value. And now it will be copied to an existing variable X in the main scope. So now X equal to 340. And this 340 feel free to go as well with the activation record. It's 100% clean here. Okay, if we understand this topic, everybody, you feel really satisfied with this explanation. You don't need to have dinner. That's how I feel when when I when I learn something cool. I don't need to have dinner. Already full. Yeah. So on line number 346, right? On line number 346, again, we are receiving an R value on the right side, from the right side, and we are storing in X1, right? It's a very simple statement from the 210, but now we learn really technically, what happened in the back. Everybody's good with this one? Can we move on to the next one? Can we move on to the next one here? Yes? Who's ready to move on to the next one? All right. So for the next one on line number 349, right? There's an arrow. There's an arrow with this statement. Why is that? Why is there an arrow with this statement? Right? If we understand, my analysis on line number 341, right? With the R value right here. If you understand line number 340, where we talk about deep copy, then you will see line number 349 very clearly. Same as line number 313, can make an L value reference an R value. That is very good. Try to reference an R value. This is very good. But be but there's something else deeper than that. There's something else deeper than that, right? Every time we learn, everyone, try to learn something new, right? You can't do it if it's not constant. Okay, so Jay is probably looking at line number 351, saying that if we add the keyword constant on the left, it works, right? So with Jay's observation, we see this. It is true that L is the problem, right? But there's something else here. We are not making a promise that we will change it, right? Or we are promising that we won't change it, right? Are we all good here? So what's going on here? And the video that Jay watched was a good video, and we need to watch more than that video, right? Because you notice here that I gave you C plus plus 0, right? And this is the O C plus plus, the traditional C plus plus. Okay, it's not the modern C plus plus because there's a big problem here. And let's listen to this. Let me analyze it for you here. So now, first of all, in this statement here, the problem with this statement is that we cannot reference an R value using an L value reference, right? On line number 349. In the old time, on line number 351, they said that I'm going to put a constant in front of my receiver and that's going to work, right? However, it actually did not work, right? This did not work. C++ keep changing a lot, right? So when we watch Jay's video, first of all, you want to see, when that video was posted, right? Because this one's already all knowledge. It's already all already. The reason for it is this: when we are receiving the value as a constant integer, you are saying that, okay, I received 340, but now I cannot use 340 because I say that, I receive it as a constant. I put a lock on it that I can't change it, right? That I can't change it. The only way to use it now is to say this: if this one is x3, I can make, another variable, for example, x7 equal to x3. So now x7 gonna have value of 340 with the no constant, right? And you can change it. But the problem here is this: you waste another line of code, another command, right? To make another copy in order to use x7. And then you waste twice as much as memory. Don't think of it as, an integer only, right? What if it's a big object like the dictionary database, right? So the problem of double memory here and extra operation, that's mean when people look at your code, right? On line number 349 to line number 352, they say, well, so far you only learned the traditional C++. It's not efficient. It's not good because you are using too much of memory and you are using too many operation just simply is to receive, an R value, right? So what is the best way to get this done? On line number 345, right? On line number 354. On line number 54, you notice this, right? The type of the receiver is a full integer. There's no constant on it. There's no constant in it. So after you receive it in X4, you have both access and control. And now you already received 340 from the right side. And you were able to do this because you understand the idea of R value reference. Everybody see it now? Everybody sees the difference between traditional and modern C++? And here, and in this case here, you are not making, any unnecessary copy. You are not wasting any memory, right? And you are not wasting any operation. Why does constant make the assignment possible? The constant makes the assignment possible because of this, Joel. Very good question. On the right side, we have a return, right? On the right side, we have we have a right an R value. R value means what? It's a temporary value. There's no identity, right? That means you cannot change it. So on the right side saying, I'm temporary, you cannot change me. That means I am constant. That's what you mean by you can't change me. So if the right side say constant, in order to receive it, on the left side, you have to be constant in order to make the deal. And this is back to package number 3. Does it make sense now, Joel? Right? But the problem here is that we are trying to brute force, trying to make it work. And we jump into this situation on the right side when we are wasting, memory and copy operation. That's why, that is not the best way. And it is already all C++. So this example here really give us an explanation why knowing, R value and, and R value reference is so important, right? And after this package, everybody, we are going to move to modern C++. And this is the transition. Any question here? Any question here? Everybody, any question? That's right, Jay. Yeah. So it's very nice that you use the time to watch the video, and now you have more information here. Okay, the video help you understand line number 349 to 352, and that was the traditional C++. The modern C++ is on line number 354 and 355. Okay, I don't think there are many videos about modern C++ yet. So on line number 357 and 358, I give you another example, right? I give you another example here with X5, only to show you this. On the right side, you see that it is very clean. It is very clean, right? We can create, separate objects, right? Okay, and receiving it, and it has you have full access and control to the variable, both X4 and X5, and there's no constant there. Okay, and that's how we want to receive this value. So Harry says, so R value reference leaves us with both access and control. Exactly. That's what we are trying to receive here from line number 338, right? Everybody see here? So we are back, we were talking about everything in 210, right? But in 210, we only saw the service layer. But now we break everything down all the way to the memory to access and control. So this simple, returning integer, but we see a lot more in that now. Okay, so I hope that you like it. All right. Any question here before we move to the next page, everybody? Any question here? Any question here? Jay don't like it? Well, you know what's more important, Jay? It's more important that it like you. Okay, so don't worry. All right, next page. On line number 362, right? On line number C 362. On line number 362, I remember reading a book, everybody. The first argument was, do you believe in God, right? And they talk, and then they conclude that actually it doesn't matter. It matters if God believes in you, right? That's when magic happened, you know? So, so you better believe it has nothing to lose. Line number 364. Online number 364. When you go to the interview, in order to evaluate if you know more than C++ or not, right? They usually ask this question, everybody. R value references have memory address and size or not? What's your answer? What's your answer? R value references have memory addresses and size or not? When they ask this question, right? When they ask this question, um, if we don't know what R value is, then the interview ends right there, right? So they know what you don't know. So, but now if you know R value, then this is a chance for you to show off. How would you answer this question, everybody? How would you answer this question? How would you answer this question? If they ask you, a question, a same question, if it's asked at the beginning of an interview or is asked at the end of the interview, you got to answer, the same question different ways, everybody. Okay? You receive a question at the beginning, that question is to warm up. That question is when they want to know, your background and how much you know. But later on, if they ask kind of the same question toward the end, you want to give a very short answer and get to the point right away. So if they ask this question, at the beginning, that's when they want to know if you know traditional and modern C++, then you better show off, right? And then you would write a piece of code, for example, what you have here, and just explain it. You said, well, um, um, online number, you would say, if we have a x variable equal to 340, we can give a reference to the variable because the variable here is already have a name, and a reference is basically a new name to an existing name. And the characteristic of reference is that if you print out the address of the object and the address of the reference, you're going to get the same address. If you print out the size of the reference and the size of an object, you're going to have the same size because in the back they are using a lookup table, right? And the reference and the object, they are actually the same, right? And you start to make the transition. You said in modern C++, this reference here, we actually call it an L value reference, right? And that means a non-temporary reference to a non-temporary object. On line number 365, right, when we say x equal to 340, we are actually binding, we are actually giving a name to a temporary variable the very first time. So in modern C++, if I need to rewrite this statement, I would write it like this. I would say integer, right, double ampersand x equal to 340, right? Because on the right side, I have an R value. And on the left side now, I need to give an R value reference to reference that, value. So let me answer your question, right? You say, okay, so now if I write an R value reference on the left to reference an R value on the right side, that R value reference, if you print out the address, it's going to have the same address as the object. If you print out the size, it's going to have the same size as the object. So yes, R value reference have memory and size. And the reason is that it is actually the same object, right? That used to be an R value on the right side. And that's it. So, you can write a quick piece of code and you can show them that from, basics advanced to modern C++. Everyone's good here? All right. Question, yes. Yes, Harry.
So if we get an R value from a function, which is not in the main, and then like in the main, we declare an R value reference to that function, to the return type of that function, then the R value reference would have its own address and size, right?
Yes. And that's exactly what we are talking here. And it makes a perfect connection to the last example.
Yeah.
And your question is actually on line number 346.
Yep.
We are
Mhm.
receiving an R value from a function. And
Mhm.
now we are storing in the scope of the main. And x1 now has its own memory and size. Make
Mhm.
sense here?
Yep. Yep. Yep.
Yeah. Okay, good. I do my best to always connect all the example. Okay. The next example always recap and explain more about the previous example, and we learn something from it. Right. So that's how I build this actually. Okay. So now on line number 385 to line number 388, this is a very important sentence. Right. It's not even a paragraph. And let's keep this because it gives us the transition to the next topic. Okay. Let's see what it's saying here. The central concept is that since an R value store a temporary object that is about to be destroyed, an expression such as x equal to an R value, where R value is an R value, can be implemented by a move instead of a copy. There we go. So from here until the end of the semester, you're gonna hear a lot about move and copy, right? And we're gonna have a package just to talk about move and copy for you. And move and copy, that's what they're gonna ask you a lot in interview. Often moving an object state. There you go. We're talking about a state here. This is the same example as changing Mickey Mouse from L to R or R to L. It's much easier than copying it, as it may involve just a simple pointer change. Okay, a simple pointer change. We're gonna take about half a package just to understand what it means by a simple pointer change. But what we see here is this: from the beginning to the end of this sentence, all the way to what here. We understand exactly what's happening, right? Last time we have uh, M, a Mickey Mouse, right? We have the M, and we were able to convert it from L to R, R to L, and the memory didn't change, right? But in the last example here, a very important example of on line number 349, if we did not receive it in the right way, we did not know how to change the state of a variable, if we did not know how to move things, then we end up doing things like this on the right side, wasting more storage and operation just to receive a variable. Are we all good? And if it's a big object, it takes a lot more work. And we're gonna learn more, and actually package number 8, right? This is going to be the focus of package number 8. All right. So I give you now, that's so that you have a smooth transition to package number 8. Another example. Another example to sum up this topic, right? We talk about L and R value. We're talking about the function design. We're talking about function calls, right? We're talking about function return, right? So let's talk about function call for L and R values. All right. So on line number 397, we had a random item function, everybody. Okay. We have a random item function. On line number 402, we have another random item functions. I give you three tests. On line number 412, on line number 416, and on line number 420. Everybody is calling random function, random item function. So our job now is this, to identify, okay, 412. Did we call the first item function or we call the second one? And the same question for 416 and 420. And most important is to explain why. Okay. So let's take about 5 seconds, please. And this is the example going to wrap up, this package here. No, you can't. No, you can't. You have to convert it, Tony. Oh, by the way, everybody, have you asked yourself the question, if you register for classes in the fall, right? First day of class, where are you going? How do you find your class? Everything's on Zoom now. Where are you going to class on the first day? Monday, wake up, right? They're like, oh, where should I go now? That's right. But be careful. Some professor do not open iLearn until second week of class, right? So check on iLearn, check your SFSU email. If you don't hear anything, reach out to them. If they don't answer, reach out to the department, okay? I don't want you to have no class to go on Monday. So it will be interesting to see what happens this semester. Last semester, right? It was a surprise, not a pleasant surprise, but we were lucky because at least we have 3 weeks together before we move online. So that helped a lot. And now we start everything from the beginning online. So it will be a different dynamic this semester. It's going to be very different in the fall, very different, especially for non-computer science and non-science classes. That's where technical problems happen more. So if you are a computer science class in an English class, for example, you may want to offer help to your professor. Okay. Yeah, and you may want to say, I'm an upper division computer science, right? I know that online class may experience technical problem. If there's anything I can help you with, please let me know. Right? That would be very nice of you. So Kevin saying it's so hard with engineering labs. Yeah, yeah. I talked with some chem, bio, people like with all the problem on the with the lab thing. Okay, so you have enough time. Let me ask the question. 412. Are we calling the first or the second, everybody? And why? First, first. Okay, and why is that, please? Most important is why, right? So why is that? Why are we calling the first random item? Why are we calling the first random item? We are referencing an L value. Perfect, right? I don't have anything else to add here, right? But okay, let me still try to add something. On line number 412, everybody, we have passing in a vector, and vector is an L value because of what? Because vector was declared on line number 408, right? Everybody's good here? Everybody's good? So vector was declared on line number 408. And and now if we pass in, right, we having two functions on the top. One is receiving, you know, by L reference, right? And the other one is receiving by R reference. So it's pretty clear, right, that it's going to invoke the first one. Any question here? Everybody's good with this one? Any question here? Can I hear from some classmate that I never heard from to make sure that you're doing well? I want to hear from everybody, yeah, but I don't want to put anyone, in the spotlight. So please make sure that I look forward to hearing from you who are not talking. And I appreciate everybody, who do more, right? Reach out to the keyboard and texting at the same time. 416, what's happening? Thank you, thank you. 416, what's happening? 416, what's happening? Second, and why is it second? Why is it second? It's an R value. Okay, can you give me more than that? All right. Sorry that I'm being demanding here, but I want you to be very ready for, you know, interviews. Why is that? Why is that? How do you know it's referencing an R value? We pass what vector is equal to, is an R value. Okay, so you are telling me that 402 is accepting an R value. Okay, I have no problem with that. My question is 416. My question is on 416. Why is 416 invoking 402? Okay, so Kevin is getting there, right? So Kevin got there about 70%, right? 70%. 70%. Referencing an R value since it's a temporary object. It's a temporary value, it's an R value. 402 does not contain constant. Um, 402 does not contain, no, there's no constant there. There's no constant there. There's no constant there, right? And in the next package, very good observation, Mitchell, right? In the next package, you're gonna see why in O in 402, if there's a constant or not, it makes a huge difference, right? It gives you a lot of advantage with or without that keyword constant, okay? What with or without, and actually for this situation, it is totally fine to put a constant in there. Actually, okay, it's totally fine to put a constant in there. So okay, let me explain the flow of this code. Okay, so you can understand something more here, everybody. On line number 416, right? This is how it works. On line number 416, we make the call to random item, and random items say, well, I have two options. I have two options, right? And I can choose one. So Kevin gave us the first answer, right? And some other classmate who also in the same direction here, saying that, well, 416 in the parameter scope, everybody, that's what we call here. Right here, within this opening and closing parentheses, we call that the parameter scope. Things that has just happened in a split seconds, in the probably the smallest scope so far that we look at. Okay. So on line number 416, we said that in the parameter scope here, we are not having an L value, right? We are not having an existing non-temporary object like on line number 412. So we cannot work with 397. All right. So now we rule out one, right? So if we cannot work with 397, what if we have another, right? A third random item. Then how do we know which one to call, right? If the another one is also accepting an R value, right? So now the flow from 416 to 402 doesn't help anymore. We actually flow back, everybody. So in this case, we are lucky. We say, well, if it's not one, then it has to be the other. So now the problem is this: if we have these curly braces declarations, we actually don't know if that is an array, if that is a vector, or if this any other data structure that we are creating in that temporary scope, in that parameter scope. Let me give you the name here. Parameter scope, right? That's what it's called. In that parameter scope, we don't know what we are creating. So actually, we go from 402 to 416 this time, everybody. So now in 402, they say, well, if you want to work with me, you better pass to me a vector. Otherwise, I won't accept anything else, right? If you create an array, I won't accept it. So now it's actually flow back. It flow back to 416 at this point. And in the parameter scope, we start to create a new object. And it's a temporary new object as an R value object that is using hello and CSC 340 as the two entries in that data structure. So it's creating a vector right here. And it is initialized with hello and 340, and now it gives to 402. Now it gives back to 402, and they work with each other. So C++ is trying its very best right here to work with us. Are we all good? So Tony said, so if we had another function that takes an ARR, then 416 would have an error. No, it depends. It depends. What's the other function taking an uh, an uh, uh, an uh, an R value reference, but to an integer, for example? Then absolutely this is not a declaration for an integer, right? Then it's gonna work with 402. Are we all good? Everyone's good here? That's why when I explain things, I try to focus on problem solving rather than just one example. Because, at this moment, you may feel, wow, this is a good example to memorize by heart, but you don't. You just remember the problem solving because when you go to interview, they may give you 5 functions and you got to be able to reason and explain why it's calling 402 but not 408 or something. Are we all good? Yeah. Yeah, I said it can be a vector or an array, right, Otoni? And then if the third option is an integer, and this is absolutely not a declaration of an integer, right? So it will be forced back to work with a vector. Are we all good, Tony? Right? In math, we call this, what kind of technique is this? In math, we call this is narrowing, right? I don't know if you guys learned that or not.
Wait, I have a question.
Yes.
So let's say we have a same function as 402, but instead
Mm-hmm.
of saying vector string r referencing, you know,
Mm-hmm.
right? We have an array string r referencing,
Mm-hmm.
right?
Mm-hmm.
Would it still work? Would 416 still work? Because the 416 can it's passing in either an array or a
Mm-hmm.
vector, and it'll be in what is it called? An ambiguous call, right?
Mm-hmm. Mm-hmm.
So it would error, correct?
So that's why I had this example for us. Remember this
Uh,
example, everybody?
yeah,
On line number 49 to 65, right?
yeah.
I knew you would have this question. That's why I gave you the fundamental first about ambiguous core, everybody, right? So make sure we spend the time to learn the packages. I spent a lot of time to design all those packages, right? I gave us the foundation back here in order to be ready for this topic. Are we all good, right? So if we make a call that can be accessed by more than two functions, then we have a what? Ambiguous call, right? And what it means by ambiguous call, we learned all of that on the first page, right? We went all the way back to even a diagram how to create a functions. So I always try to cover from the very basics for reasons, right? I don't want to lose anybody in the middle. If I just assume I said, well, you took 210 to 20 and never give you a review, and I would jump into one topic in the end here, then my teaching life is very easy, but I would lose all of you, right? And I don't prepare you for next class. Anyway, did I answer your question, Tony and Joel? Did it make sense here? Did I answer your questions? Right? Did I answer your question here? Good? Okay. Any other question here, everybody, before we move on to the next topic, right? We still want to go to the memory layout, remember? So that we can have more help for the midterm, right? So can we move on to the next package here? Who's ready? Yeah. Okay. All right. Any question you can still ask me later. Package number 6, please. Is Mr. Isaac still here? Mr. Isaac Tang. Can we have package number 6, please? There we go. Thank you, Isaac. All right. Object oriented programming, everybody. I'm eating. Sorry for the delay. No, you're still fast. Enjoy your meal there. Okay. So, package number 6, we are talking about object oriented programming. And this is a basic package. Okay. This is a basic package because I don't want to jump into advanced right away. If I jump in advanced, I will lose you. I know that, right? So I always give you the very basics, and then we're gonna go to the advanced one. So now, in C++, everybody, on line number 1 in the diagram, well, actually line number 2, I have I have 3 models for you. Yeah, how you design, how you structure a C++ class. A, B, and C, right? And let's see, which one is this? Pum, pum, pum. The first one. The first one is a good style, right? And I'm saying that it's good just because most of people use it. It is the four structures of Visual Studio uh, C++, Microsoft one, okay? But you feel free to use the second and the third if you like it, okay? So now let's analyze it here. What's the difference between C++ and Java class? Just in the general look, right? In C++, everybody, if you declare a class, right? If you declare a class, you want to make sure you have this. You have a semicolon at the end. Are we all good here? Yeah. You need that semicolon at the end because remember that in Java, right, everything is wrapped in a class, but in C++ is not. So they treat the class declaration more like a statement rather than a structure. So you got to have that semicolon at the very end. Are we all good? Everyone's good? Hello, everybody's good here? And then the next thing is this. Make sure that we group items, right? we group all the publics together, and group all the private together. And we notice that there's a colon, everybody, okay, after the keyword public and private, right? So don't forget those, elements, please. And then we notice more in this. This is just a general look, right? So they try to keep it very simple for you. And this structure here is not completely modern yet. To make it modern, there are more work to do, but I want you to note one thing here, right? In the modern C++, all variables must be initialized right away. Must be. Right? I really mean must be. Otherwise, we run into a lot of problem, right? Must be initialized. Not like in Java, okay? So we must initialize. What does modern mean? More complicated or look better? Modern means the latest version, Jay, right? We're talking about we are looking toward to the C++ 20 now, and it's going to be coming out soon. That's what it means. So we have the traditional, the basics, we have the advanced, and we have the modern. When you graduate, they're going to use the modern C++. Okay, so now, so that is the general style, right? So on the right side, let's say this one looks more like Java, right? This one, this one here look more like Java to you, right? And this one is kind of, I don't know what style it is. Maybe it's just private and public. That's the style. So pick one if you want. So now let's look at the organization of a C++ class in Visual Studio. Okay. So in Visual Studio, in the picture on line number 4, everybody, make sure that you notice the two folders. Number one is the header files, and number two is the source files, right? Yeah, we are getting that to that right now, Mitchell. Yeah, it is a constructor. Okay. So in C++, right, we keep all the header files, and they are .h, and we in the header file folder, and we keep all the CCP file, right, in the source file. So in Java, if you have a circle.h or circle.cpp, inside there you must have circle.class, right? A circle class. But in C++, it doesn't matter. You can give any name, right? There's no relationship between the name and the content that you contain inside. However, for programming style, easy to manage and easy to recognize, if you have a circle class, you want to name it, circle.h and circle.cpp. So now what's the difference between circle.h and circle.cpp? Circle.h acts like the interface, everybody, okay? Act like the interface in Java, and CPP is the implementation of it. So if you click on circle.h, you see something like this. On the right side here, we have the declaration of the the circle class, and then you see that you only have the declaration or the prototype of all the functions, right? And you have the declarations of the property without any body, no implementation. In the source file, right? In the source file folder, if you click on C circle.cpp, on the top we see that we are including circle.h. That means we are implementing that class, and we start to give the full body to all the implementation. So now let's take a step back here. I have a question for you, right? Why do we need circle.h? Why do we need circle.h when eventually we can just work with CPP? We don't really need circle.h. Oh, there we go. Tony is asking the question, and I I asked the same question. So I kind of answered Tony's question there, right? We don't need circle.h, right? But why would you have circle.h? So Jay said because you are having other programmer who working on the same project, and then Edgar said if you want to have a different implementation, both of them are very good. Encapsulation, almost there. That's a good keyword, right? For multiple CPP, okay. Kevin is laughing, saying that it looked nicer. They don't need to read the whole program. Ah, very good. So encapsulation, and they don't need to read the whole program. Working with other people, yeah, it looks nicer, more organized as well. All of those are good, right? But we need to take a step back, everybody, right? The most important here is that you don't want to lose money. Everybody's good here, right? If you are working with a client, at one time when I was at Cisco, our client was Microsoft, and that was the best and the worst client that we had, right? The best because we did not have to give them, computer science 101. Did not need to explain to them, what we are doing. Every time we just send them what? The header file. That's it. Saying, look at this. This is what we are working on, right? We are developing those functions. Yeah, we are having this class. But you would not want to give your .cpp, right? Because if you send them .cpp, then you lose your business. You are giving all the ingredients, you're giving all the secret, right? But if you send the CPP, you send the .h, that's the easiest way to communicate with a computer science educated client. You send that, and they can read that for themselves. Everybody see that now, right? So you got to hide the secret ingredient, secret sauce, or basically that's your money. You cannot share the CPP, but you can share the .h. And in the business layer, that's all what it means. Okay, you have sometimes you have to put a lot of documentation inside your .h so that your client knows what you're doing. Depends on how geeky, how savvy your your client is. Okay, and all the other reasons that our classmate listed here, we learned from 210 and 220. Okay, so now let me get into detail here. All right, so let's line by line again. Let me erase all of this and explain in very detail what's happening. In the .h, everybody, do we place subclasses in the same .h file? Oh yeah, oh yeah. We can put in the same, or we can put outside, William, and I will explain to you why. Okay, we can use include. That's what we are doing. And the next assignment, assignment 3, gonna give you a chance to work with all of this. So if you are paying attention right now, assignment 3 gonna be very easy. Otherwise, it's gonna be pretty hard, right? So here we go. On line number 1, everybody, we have a C++. We have a modern C++ element, right? We say this pragma once. What does that mean? Pragma once means this. Let's go back to the old time first. Notice on line number 1 of the .cpp, right? We say, well, I'm implementing the class that is inside circle.h. That's what it means by, include here. And notice here, if we include something that is we define ourselves, is user defined, programmer defined, we got to make sure that we save it in the double quotes. Everybody's good, right? We want to save that in double quotes. So now, and that's answer William question. You can put everything in one file, William, or you just partition it into different file and then use include. But what if in a big program and we happen to include, the header file multiple times? So in the old time C++, this is what they do. They said, well, on the top I said if not defined, right? If I did not, include this file, then I would include it, right? And then at the end, I have to say, where it is the end of the inclusion. So this is the old time C++, very complicated, right? You got to use, three lines, three places, just to tell people where things start, where things end, right? And if not, what gonna happen if in the middle of these two labels and there's something happens and something breaks here, right? Then the program gonna crash. So in modern C++, you only need to include one line at the top, and this line means this: if it was, make sure that if you include only once in a program. That's it. Very simple. You get it done. All right. So now, what else in here? Online number 8. Everything else you know over here. Online number 8. You see the keyword constant here, everybody? So now constant has a different meaning. Okay. So Jay not gonna like C++ now, right? So constant in this position gonna have a different meaning. So let's take a step back and see what's going on here. We have a getter, right? That is returning the area, right, of a circle. And we are returning a double. But we say constant. This constant means this. I am accessing, the properties of this class in this function. And I promise that whatever I access for read only. I'm not going to change it. Everybody's good here. So in a function, right, we can have a keyword constant here. We can have constant in here, right? We can have two or more constant in here, and then we can have another constant in the back here. So easily we can have about 4 or 5 constant in one declaration of a, C++ header function header, and all the constant can mean has different meaning. Can you repeat that again, please? Okay, I'm repeating it. On line number 8, right? Let me erase all this. What do we have on line number 8, Harry? What is this on line number 8 that we have? It is a, what? It is a getter, right? It is a getter, getting the area. Everybody's good? And in order to calculate the area, right, of a circle, we got to use the radius. So at some point in the implementation of this function, we got to use radius. When we use radius, we may change it, right? But no, we say, no, 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 no. I'm only using it for reading only. I'm not going to change it. This is what the keyword constant mean in this case. Okay? All right. Next one. Next one. Let's see anything new here that I need to tell you. Oh boy, so what's going on here? What's going on here, everybody? On line number 4, right? What is that? Is Jay still here, or Jay goes somewhere else already? More headaches for Jay here. Still here? Okay. On line number 4, what's going on here? What kind of syntax is that? What kind of syntax we have in this? It's a constructor, right? But what's really going on? What is really going on? So let's focus on this, everybody. Okay. In 210, right? In 210, we learned this. We learn to declare a string this way. Into into 20 and at the end of 210, we learn to declare a string this way. Looks a little bit better, right? In 340, from today until the end of the semester, this is how we declare a string. Everybody's good, right? Okay. So why is that? And I'm going to take this opportunity to explain to you, okay? This is how we're going to do it from now on, okay? The third one, from now on. You see, I named the variable for you, right? This is the last time we do this. And in 220, it was a little bit better, right? But not good yet. And this is the one is from now on. So why is that? So what's happening with the first statement is this. What's happening with the first statement is that for the first statement, on the left side, we declare a reference variable, last time, right? String last time. On the right side, we have an R value, right? Everybody's good here? And then the next thing we do is that we got to copy this object over this object using a copy constructor. That's what we learned when we, you know, when we learned the example of deep and deep copy, right? So it takes three steps. Number one is to declare the reference on the left. Number two is uh, to create the object on the right side. Number three is to copy the object over the left side. And there's actually a number four is that we have to destroy this temporary object on the right side. That's how many steps it takes in order to declare a string in the 210 style. In 220, we are saying this. In 220, we say, I'm going to invoke a constructor to create a string. And then my string start out having an empty value, right? There's nothing in there. And then I receive a hello 340 in the parameter. And I'm going to copy hello 340 over that default value, right? So there are two steps in here. You declare a default value, a default string, right? And then you use hello 340 from the parameter list and you copy over. That's take two steps. In modern C++, we don't do that. In modern C++, we use a curly braces, right? And we call that the initializer list. Initializer list. And what it's doing is this one shot, right? That's it. One shot, no extra step. It says this. Can you give me can you give me a string? And I'm gonna create an object with that string. There's no default, there's no copy, there's no delete, right? There's no temporary, nothing. Okay, if you give that string, I'm gonna keep that string and I'm gonna create an object using that string. Done. So what really happened is this. Number one, right? Let me explain from left to right. Because we are in the .cp file, so we have to say, I'm implementing, let me use a ruler to keep it nice and neat for you. I'm implementing this constructor that takes one parameter for the circle class. I'm creating it for the circle class, right? Or if we read from left to right, we say this. I'm accessing the circle class, and then in the circle class, I'm implementing the constructor for that class. Are we all good, right? So the double ampersand here, the double colon operator here, we call that is the scope resolution operator, everybody. It is a scope resolution operator, okay? An operator that takes us to the right scope, right? So in this case here, is take us to the scope of the circle class and go into the constructor. And now, in the constructor, what happened? In the constructor, what happened? In the constructor, we said this. So in the old time, right? In the 220 time, right? We did the initializing of the object inside the body, right? So in the body, what we did was that step number one, we call super, to create empty string. And line number two, we're gonna use a string from the parameter to create the object. So it become hello 340, right? So now for the modern one, when we use an initializer list, this is what happening. We don't even go in the body. We don't even go in the body, right? We don't even go in the body. We said this. If you pass in a radius, right? If you pass in a radius, I'm going to copy the radius to the right side. And then that radius going to become the value of my radius. And that's it. We do it even before we get to the body. And we don't even use the body of the, of the constructor in this case at all. And that's why it is an advanced way. Okay. And behind there, the main idea is the R value. And that's it. Any questions here? Any question here, everybody? Do we see what's happening here? Do we see what's happening here, please? Everybody's good? Everyone's good here? Okay. So now, at the bottom, um, let me see anything. This is all good. At the bottom, there's one more detail that I want to give you. Online number 7. Online number 7, right? Online number 7. In Java, right? This is very important. This is really important for this line. In Java, with this declaration, everybody, we have only a reference. We don't have an object, right? Okay. In C++ and modern C++, this code here actually create an object for us. So be very careful with this one, right? And it means a lot when it comes to memory management and memory optimization here. Are we all good here, everybody? This declaration create an object. In Java, this declaration only give you a reference, ready to reference an object. Okay. So on line 11, right? On line 11, if we aim to, if I mean, if we are using the terminal, right, on our computer to compile a program in C++, make sure that you use that whole command line, right? So dash O here means the output file. So we got to put together the header file, the implementation of that header, the client file that using that implementation, right? And then after we output, we say, what is the name of the C++ executable file that you want to name? Then you say, I want to name it circle. So when you execute circle, you run circle, you have, everything's in there. But on line number 7, we don't create the object with a value for radius. So is radius no on line number 7. On line number 7. 7 here? Is that what you're asking, Mitchell? Okay. So what is radius? Radius is from here, Mitchell. Radius is on line number 11, right? Remember I said in C++, we always have to initialize, our properties, right? That's a good question, by the way, Mitchell. Um, in C++, I was to point out on the next page, but let me point out right away since I see the syntax here. In C++, right, we use the initialize the list almost everywhere, everybody. So on line number 11, we right here, right, we use the initialize list instead of saying, double radius equal to 1. Okay, we say double radius, and then we put in the initialize list in order to initialize our variable. I'm more asking the difference between declaring an object as circle 1 compared to circle 5.0. Well, if you put 5.0, then you're gonna override the default value with 5.0. Does it make sense here? Because this declaration here gonna copy 5.0 into radius. Did I answer your question, Mitchell? Does it make sense? Yeah. Okay. Wonderful. All right. So now we have 10 minutes left, everybody. I was to finish package number 6, but I remember last time we have a presentation, so we are a little bit slower than the other two section. I suggest this. Can I go to package number 7 to give you some more help with midterm, right? Even though you already have everything ready, and we can continue with package 6 next time. Is that okay? Yeah. Let me show you package 7. Yeah. All right. So let's go to package 7. We've been practicing already. So let me give you package 7s here. In package 7, we start out with a diagram, a very big diagram, very important diagram. And then we going to have some practice in package 7, right? Whoa, wait. How can package 7 be so big? 1, 2, 3. Package 7. Oh, it makes sense. Okay, so that diagram On the PC, you can turn it around. On the iPad, you cannot. So I give you the diagram only, right? I post that for you so you can look at it. Okay. So for the diagram only, let me give you some overview of this diagram here. Okay. So now we have 5 area, right? All right. Everybody have the diagram here, the diagram only, yeah, so that you don't have to turn things around. So you see the 5 areas that I gave you. So right now you look at this diagram, you are not scared, right? That's why I did not want to give you this from the first day of class, because we explore, area by area already. So here we go. We learned that the first area is a command line environment, right? And that's where we interact with the outside world. The second area is the runtime stack. This is where we store the local automatic variables, right? Passing argument, we learn all of this. Returning address, current status of the memory. And this is where stack overflow happens because it is a memory stack. Everybody's good here? That happened during runtime. And then we have unallocated memory. And the reason for this is that area 3 is on demand, right? This is an on demand so that this area can, take memory from the unallocated or return the memory when it doesn't use it. So the free store, right? We store all the variable and dynamic objects whose memory was allocated using the keyword new. There we go. If you see the keyword new, you know that the object is saved in the free store. Objects in here never fall out of scope, right? It's gonna last until the past the end of the program, right? Past the end of the program until we delete it. Everybody's good, right? Otherwise, become a memory leak. We must always destroy using a delete, right, within the program. This area is responsible for memory leaks. We learned this, right, with the dangling pointer. If you run a program and you see, fragmentation and allocation failure, you know that there's a problem with the free store. Okay. Now, in area 4, everybody, the exam doesn't go to the midterm doesn't go to this depth, but I'm going to explain to you more. In area 4, and that is the area we call the data area, we split it into 2 areas, A and B, right? In area A, we store, all the uninitialized, variable. And in area B, we store those are initialized already. And what are those variables? They got to be global and local, right? We store all the global and local variable in area 4. If they are initialized, they are in area 4B. If they are uninitialized, they are in area 4A, right? In the old time, going back to the dinosaur time, they call this the BSS area, or it's also called the block started by symbol area, right? And then we're gonna learn more about the default value next page when we have the code. Okay. So if you take a step back, and let me introduce area 5 also, we talk about it, right? The binary, the executable, some people call this the text area. So, but if you take a step back, right, this is how it's organized, everybody. The lower address is from the bottom, and the higher address is on the top. We go from 5 to 1. The lower address, the lower addresses, that's where we have read only, right? Because it is the code of the program binary, so we can't change it. And when there's no change, that means it's not active. That means we only are reading that code only. We are running the code only. So it's less active at the bottom and it become more active on the top, because right here, right? Everything here is inside the program, and up here is interacting with other programs and other servers. At the bottom, we have the executable code, right? So this is the code of the program. And then we extracting from that code, right? We extract all the initialized value first. And then if it's not initialized, we start to initialize. That's why it's more active. This is a code that we run. This is, those are all the variables that were initialized. Those are the variables that are uninitialized that we need to initialize. In the area 3, the area that where we create very big objects, right? So more activities, right? We constantly create and delete, and it expand, and then it collapse, right? On demand. And then we go to area 2. That's where we manage all the activation records, a lot of function call. It constantly optimize, constantly, push and pop. That's why it's getting busier and busier in area 2. And then, if one program is busier, thinking about we working with other programs outside, it even more busy, right? More busier. That's why it's more active to the top. So that is explanation for this diagram. On the left side, I kind of explain it here and there for you already, right? And then I'm going to use a code to give you more information, all right? So now let's go to the code. Package number 7. In package number 7 on page number 2, right? On page number 2, I may need to ask for 5 minutes today because I want to walk you, I want to give you more example for the exam. Is that okay with everybody? Okay, is that okay, everybody? If I have about 5 minutes. Um, all right. So here we go. In the first example, what I gave you is this. On line number 5 to line number 9, I give you a bunch of variable in what scope, everybody? Thank you, William and Isaac. What scope is line number 5 to line number 9? What are those variable? Those are global and what? Give me one more. They are global and uninitialized. Are we all good? Every time we learn something more, right? Last time we learned global already. And this time we learn global uninitialized. So if they are global, they are in area 4, right? If they are uninitialized, then they are in for A or for B. They are in for A, right? Uninitialized is in for A because we need to initialize it, right? And let me get back here. Uninitialized is in for A because we need to initialize it. Just think about what is less active and more active, right? If it's initialized already, that means we don't have to initialize. If we don't have to initialize, that means it's less active. If it's less active, it has to be at the bottom. If it's in the bottom, it has to be for B. So if it's uninitialized, that means it's more active. It's more active, it has to be on top. If it's on top, it got to be for A. All right. So that is the logic. Nothing to memorize here. So now I have a certain rules for you. Okay. If it's global and it is uninitialized, everybody, or is explicitly initialized to 0, right? If it's uninitialized or explicitly initialized to 0, it will be stored in area A, right? So uninitialized or 0, even if it's initialized but to 0, it will be stored in area 4A. So please remember this detail here. So now if we go back here to the example, what I gave you is this. If you in the code, right? In the code, um, let me read the code quickly here. We having a function on line number 11 to line number 15. We are testing to see what is the value of local static, and we're going to use it later. On line number 18 to line number 20, you only need to see that I'm using Visual Studio Professional 2019. By the way, for all the rest of the packages that we learn in the class, make sure that we update our Visual Studio to the latest version, right? Otherwise, you will not see, a lot of information that we need to learn here. So all the example here are just to test, if it is uninitialized, what Visual Studio will do to those variable. You look at the output here, right? You look at output here. If it is a numeric type, right? And if it's global and it's integer, it is initialized to 0. If it's global, it is double, is automatically initialized to 0. It is global uninitialized a pointer. Will be initialized to 0000, right? And that is a no pointer. Please remember this one. We learned this. If it is a character, right, it is uninitialized, it will be a no. If it is a no for the ASCII code, right, that's equal to 0, right? If you look at it as an integer, if it's a string, it will be an empty string. If it's a string, it will be an empty string. And if it's a local variable, right, and it is uninitialized, and it is a static, so that is in area 4, it's going to be 0. And when it's equal to 0 and it is uninitialized, that's going to put that in for A. Everybody's good here? So here we go. That is for A. All right. So after that, we're gonna have an example to do here. So now let's do this example, and that's all we need for the midterm, right? On line number 41 to 60, can you identify three things, right, for all the variables that I underlined already? Okay. So let's work together here so we can get out of the class, everybody. On line number 42, what area are we storing X code and why? 42, what area are we storing X code and why? For line number 42, everybody. What area are we storing X code and why? Uninitialized, right? And in the last example, is automatically initialized to what? It's automatically initialized to 0. So it is stored in what area? It's stored in area 4. When it's global, we know it's 4, right? And it's uninitialized or 0, it's going to be in 4A. Everybody's good now? Any question here? It's going to be in 4A, right? Next one, student code, right? Student code, where is it going to be? Student code, where is it going to be? So I give you a rule here, everybody. In a class, right? If it is a static variable, right? It will not be initialized inside the scope of the class. This is what we should have learned in package number 6. But our section's a little bit slower, so I'm going to give you this point here. So if it's a static variable, we're going to initialize it outside of the scope of the class. We're going to jump to line number 51 to declare. Everybody's good. We're going to jump to 51 to declare. If it is non-static, we're going to declare it inside the scope of the class. That's what happened on line number 48. Everybody good. So now, if we initialize it on line number 51, right, at first, right, then it is in what area? It is already initialized, and it is what in what area? It is in area 4B. Everybody's good here? It's in area 4B because it's already initialized. This is a special one, and it's more important that we understand. Don't worry about the exam. For the exam, if you put for A or for B, I still give you full credit. Doesn't matter. But for the interview, make sure you are able to initialize to explain the flow of the data, how it gets created, what area, and where it's stored, so that they know that you know what's going on. On line number 55, right? Student. Where student is stored, everybody? Where student is stored? On line number 55, where is student store? Student is what? Student is static, right? Whenever we see static, we know that it's going to be in area 4. Everybody's good here? Whenever it's static, it's going to be in area 4. So now the question is for A or for B? For A or for B? For A? Be careful here. Can we have an object that is not initialized, everybody? I know that you don't see any equal signs here, right? But can we ever have an object that's not initialized? No, right? The constructor always initialize an object. So be very careful, right? This is have to be for B. It has to be initialized. If it's an object, it has to be initialized. And this is an object of the stu type, right? It has to be initialized. So on line number 56, where is this store, everybody? Where is this variable store? This is another object, right? It is another object. Where is it stored? It is a student object, but it is in a very good hurry. It's stored in area 2 because it is a local variable of the function func, right? Local variables is in area 2 if we refer to the diagram. Everyone's good? On line number 61, where is student pointer store? Same as pointer 2. Where are they stored, everybody? Pointer, student pointer 1 and pointer 2, where they store? They are pointer, right? This is what we learned from package number 3. They are stored in the activation record of main. So they are in area 2. Everybody's good. Where is the object on the right side of line number 62 store? Where is this object store, everybody? This is more than, it is going to be area 3 because of the keyword new, right? Are we all good here? Where is the object on line number 61 store? We have an object on the right side here, right? Where is it stored, everybody? We have to look back at the function. And function is returning the address of student, and student was created on line number 55. And we know that it was created in area B, 4B, right? So that's where the object is. Okay, can I take any questions here? So basically, that was, and remember this, right? If it is on area 2, it in the activation record, the lifetime of it is the duration of the function call. If it's in area 3, right? And if it's deleted, right, then it is the lifetime lasts until it's deleted. If it's not deleted, then it passed the lifetime of the program. Everything in area 4 gonna last until the end of the program, right? Everything in area 5 gonna last until the end of the program. And that's all the rules that we have for the lifetime of the object. Kevin is asking, can you explain why the last one in area 4 again? Okay, let me clean it up, right? And explain why it's in area 4B again, right? Here we go. So we're talking about line number 61, Kevin and everybody, right? And this here, this object here, right? Is that this one, Kevin? So now, 61, object on the right side, where is it? This object was the object returned from the function, right? And the func function is returning the address of student. And student was created on line number 55. On line number 55, it is a static, so it has to be in area 4, right? And it is an object because every object is initialized by the constructor. So it has to be in area 4 initialized. So it has to be in 4B. Does it make sense now, Kevin and everybody? Does it make sense now? All right. William, can you repeat what is the lifetime of area 1 to 3? All right. 1, 2, 3. Okay. Let me open the diagram so I can give you better, visual explanation of what's going on. Okay. Let me even erase all of this and give you better explanation too. All right. Area 1, right? I'm not going to ask about area 1 yet, so don't worry about it, right? Don't worry about area 1. Area 1 is more complicated than the other area, and I want to give a lot of information. So let's wait on that. Area 2, right? What is the lifetime of objects in area 2, everybody? We've been learning this from package number 2 already, right? So if you want to understand, you want to go what? In area 2, we store activation record. And activation record, they start at the beginning to the end of the function call. So objects, right? In area 2, in general, the lifetime is the duration of the function call. That's it. Does it make sense? After the function call, the activation is pop, right? Activation record is pop. So that is the lifetime of the function call. Those object in on runtime is lifetime of function call. Area 3 is written here, right? Whenever we declare an object in area 3, we use new to declare. We use new to create, and we can only get rid of it by calling a delete on it, right? So now, if we call a delete before the end of the program, then it's gonna end right there where we call delete. But if we don't call delete, then it's gonna pass the lifetime of the program. Even when the program ends, it's still there as a memory leak, right? Okay. So I answer William question. Did I, William? Joel, so memory management is based on how long you would want certain object to last. Exactly, that's what it is, Joel. Exactly. Well, the keyword management here is more like how much control you have on the organization, on the size, and on the lifetime of those objects. That's why we talk about the lifetime, and we talk about the scope, and we talk about the area. That's it. Area means where is it? Area means one, two, three, or five. The scope means what? Is that in a function call, right? Is that in a main or whatever? The lifetime means where it start and where it's end. And that's all. Use Java so you don't worry about the whole memory. Okay, thank you, Jay. All right. Thank you, everybody. Have a very nice weekend, right? Do your best. And the whole point of the midterm exam is to learn and review the material, everybody. Okay? There's no pressure there. And we're going to go over all the questions together next week. Thank you so much. Have a very nice one, right? Yes, I always have office hour, Jay. Okay, 4:30 to 4:55. 4:25 to 4:55, Monday to Thursday. Thank you so much, Mitchell. Thank you. Thank you. Okay, I hope I gave you all the explanation. Thank you so much. Have a nice weekend.